Good morning, everyone. Yes. So in the previous class, we were discussing about the ligands, right? So what are ligands? What are the different types of ligands? So we have discussed monodentate ligand. Then we are dealt with the polydentate or multidentate ligand. So in polydentate ligand, we have seen what are polydentate ligand when you have two or more ligands. Okay, so they are termed as polydentate ligands. So we have seen bidentate, tridentate, tetra, then pentadentate and hexadentate ligands. So these were the polydentate ligands which we had discussed. Then later we have discussed about the amphidentate ligands. Yes, can anyone tell me what do you mean by amphidentate ligands, students? What do you mean by amphidentate ligands? So we have discussed three examples also on that, right? Yes, nobody? What do you mean by amphidentate ligand? Amphidentate ligand means what? If a ligand have two or more donor atoms, right? Then complex is formed by only one. So only one. So out of those two donor atom, only one atom will it will be used in the attachment. Okay, so only one donor atom is attached to the central metal atom, so they are called as amphidentate ligand. So in the same particular molecule you have you have two or more donor atoms. So which were the examples we have discussed? Cyanide group. So in cyanide, it can link from carbon also, it can link from nitrogen also, cyano group. Then we have discussed about thiocyanide group. It can link from your, what is this? Sulfur group as well as from your nitrogen. Then we had discussed about nitro group. So it can nitro group, it will link from nitrogen. Also, it can link from your oxygen, right? So these are the amphidentate ligands. So in the same molecule, you have two or more donor atoms. So only one atom will one donor atom will get attached to the central metal atom. So such ligands are called as amphidentate ligands. Okay. Then also we had discussed something called as chelating ligands. Yes, anybody? What do you mean by chelating ligands? What do you mean by chelating ligands? Chelating ligands are what? A bidentate or a polydentate ligand which when attached to the central metal ion, okay, will form a ring structure. Okay, it forms a ring-like structure. Okay, so this also we have discussed. Okay. So next, we had discussed about the coordination number. Right, we had discussed about the coordination number. What is coordination number? The number of ligands which is joined or bonded directly to the central metal atom is called as the coordination number. So based on the coordination number, we have seen the geometry of the complex also, right? So so coordination, your geometry is of the complex is related to the coordination number. So depending upon how many ligands are present, they are bonded to the central metal atom. Okay, the complex is decided, the geometry is decided. So if you have two ligands and there is one central metal atom, then it is a linear. If you have coordination number 4, so two possibilities. Okay, there are two possibilities. One is a tetrahedral, another is a square planar. Then if you have coordination number 5, then you have two possibilities again, trigonal bipyramidal and square pyramidal. So I've shown you how, okay, and here also they have given the structures. So again, whoever have not attended the class yesterday, so you can go through the structures here. So this is a square pyramidal, this is a trigonal bipyramidal. And when you have coordination number 6, you have octahedral. Okay, so 4 atoms at the 4 corners of square, and one above and one below. Okay, so this is about your geometry, okay, which is related to coordination number. Next, we are going to discuss is the coordination sphere. Okay, what do you mean by the coordination sphere? Okay, so the central metal atom. So central metal atom is represented by what? M, right? The central metal atom is represented by M plus L, okay, Mn plus. So central metal atom or the ion, okay, so along with the non-ionizable ligands, when they are enclosed in a sphere. Now M, suppose M, and I'll write it as L4. Okay, L4 means what? This represents your what? Your ligand. Okay, the number of ligands. So how many ligands are there? 4 ligands. So when metal is linked, okay, so when your metal is linked to the ligands, okay, so your how many ligands, non-ionizable ligands are there? 4 ligands are there. Okay, so these 4 ligands, so how it is represented? Suppose metal is in the center, 1, 2, 3, and 4. Okay, so these are the 4 ligands. So like this we represent. So this, okay, so when the metal along with the non-ionizable ligands, when they are enclosed in a square bracket, okay, they are enclosed in a square bracket, then this is called as coordination sphere. What it is called as? It is called as coordination sphere. So a central metal atom, when it is enclosed, okay, along, or when it is linked or when it is bonded to the ligands, and when metal and ligands, when they're enclosed in a square bracket, so these are collectively called as, okay, it is called as a coordination sphere. So like this, so we write, right, K4 FeCN6, right? So here what we represent, what we can see that the central metal is Fe, okay, and the 4 cyano groups, okay, these are the ligands. Okay, so the metal and the ligands collectively, they are enclosed in a square bracket, and this completely it is called as coordination sphere. Okay, what it is called as coordination sphere. So let us see example. Let us see example again. K4, okay, FeCN6. Okay, now here, which is the coordination sphere, students? So this is the coordination sphere. Okay, so this is your coordination sphere in the bracket. Whatever it is written in the bracket, okay, this represents your what? This represents your coordination sphere. So please remember the terms, what all we are using. So this is called as coordination sphere. Okay. And this K4, what is written here? Okay, this K4, what is written here? Okay, K4. So this is a counter ion. What it is? It is a counter ion. Okay, this is a counter ion. So this can also be written as, so if you don't want to write this K4, then you can write it as FeCN6 minus 4. So the charge will be shifted like this, minus 4. Okay, so this is the other way. So if you don't write this counter ion, so to compensate this minus 4, we are adding plus 4. Each potassium is plus 1. So we are writing K4. Okay. So like this, either you can write like this or this. So if the bracket represents what? It represents your coordination sphere. So the ionizable groups are written. So the ionizable means what? When you add it in water, okay, they will get dissociated. Okay. So the outside the sphere, what you are writing, so these are the ionizable sphere, ionizable groups. Okay, so these are the ionizable groups. The outside the sphere, what is there? And these are non-ionizable. Okay, these are non-ionizable. non-ionizable ligands. So these are non-ionizable. Okay. So the ionizable groups which are written outside the group, they are called as counter ions. What they are called as counter ions. Got it? Is it clear what is coordination sphere, students? Okay, fine. So next we are going to see is coordination polyhedron. Okay, coordination polyhedron. Coordination polyhedron. So what do you mean by this coordination polyhedron? Okay, so the spatial arrangement of the ligands, okay, which are directly attached to the central metal ion, means how the structure is represented. Okay, how the coordination structure is represented. So you can see the metal is if it is linked to four corners of the square planar. You can see it represents what? It represents that the metal is linked to four groups or four ligands at the four corners of a square. So this is called as square planar. Okay, this is called as square planar. Here you can see, okay, two are on the plane. One is okay, near to the observer, one is far to the observer, right? So this represents your tetrahedral geometry. This represents your tetrahedral geometry. Then these three are okay, this triangle is in the plane. Okay, so it is in one plane, so this is a trigonal, and above one and below one. So this is a trigonal bipyramidal. Okay, it is trigonal bipyramidal. Then what is square pyramidal? So metal is in the center. So at the four corners, you have four ligands and one above. So this is what? It is a square pyramidal. Okay, it is a square pyramidal. So when you have geometry 5. So this is 4, 4, 5, and 5. And octahedral is what? Again, metal in the center. At the four corners, you have four ligands. Okay, and one is above and another is below. So this is what? This is a octahedral geometry. Okay, octahedral geometry is when you have six ligands. Okay, so the spatial arrangement, whatever the spatial arrangement is there of the ligands, okay, which is directly attached to the central atom, it is called as a coordination polyhedron. Polyhedron means how the structures are represented. So the most common polyhedrons are your tetrahedral geometry, square planar geometry, and the octahedral geometry. So mark this important. So mostly what you can see is this geometry. Okay, so the most common coordination polyhedrons are tetrahedral, square planar, and octahedral geometry. So this represents what? This represents your coordination polyhedron. Okay, this represents your coordination polyhedron. Fine. Then next we are going to discuss something called as homoleptic and heteroleptic. Okay. Now, what do you mean by homoleptic? Important, mark this as important, students. Important 2 marks question. Important 2 marks question. Either they can ask you what are homoleptic complex, give example, or they can ask you what are heteroleptic complexes. Okay, give example. So either of this question can be asked for 2 marks with example. Okay, with example. So what are homoleptic complex with given example? What are heteroleptic complex? Okay, what are heteroleptic complex? Give example. Okay, mark this important. So let us see the example. So complexes in which the central metal ion is bound to only one kind of donor atom. Means what? Means what? So M, okay, if it is linked to only one type of ligand, okay, so then it is called as homoleptic. Homo means same. Okay, so it is linked to only one type of ligands. Okay, one kind of donor atoms, then they are called as homoleptic. So let me give you example. For example, cobalt, NH3, 6 plus 3. Okay, so you can see that cobalt is linked to only one type of donor atom, which is the donor atom. It is amino group, right? Amino group, amino. So the name is here. How many atoms of amines are there? 6. So 6 means hexa. Okay, hexa amino cobalt. Okay, okay. So hexaamino cobalt. So this is a, so when the central metal atom is linked to only one kind of donor atom, then they are termed as homoleptic. What they are termed as homoleptic. Next is heteroleptic. What do you mean by heteroleptic? So complexes in which the central metal atom is linked to more than what you can say, uh, okay, if it is bonded to more than one kind of donor atom. Okay, what you can see here, a central metal is there. Okay, one type of ligand, they are 4 in number. Another type of ligand, there are 2 in number. Okay, so what type of geometry it is forming? It is forming a octahedral geometry, right? So metal and 4 plus 2 is 6. So 6 geometry, whenever you have coordination number 6, so what it means, it has a octahedral geometry. So what is the heteroleptic? Write down the definition. So complex in which metal ion is bound to more than one kind of donor groups are called as heteroleptic. What it is called as heteroleptic. Okay, so let me give you example. So cobalt NH34 Cl2. Okay, so plus 1. So this is your example of heteroleptic. Is it clear what is homoleptic? What is heteroleptic? Yes, is it clear? So what is homoleptic? So metal, okay, if it is linked to only one kind of donor atom, then they are called as homoleptic complexes. And what do you mean by heteroleptic complexes? When the complexes in which the central metal ion is bound to more than one kind of donor atoms, donor groups are called as heteroleptic. Is it clear? The difference between homoleptic and heteroleptic? Yes. Any doubts up here? Okay, fine. Okay. Next, we are going to find the oxidation number. Okay, next we are going to find the oxidation number of central atom. So how to find the oxidation number of central atom? Okay, oxidation number of what? Central atom. So let us see. Next is oxidation number of central atom. So what do you mean by oxidation number of central atom? So it is the charge. Okay, it is a charge which is carried by the central metal atom in a complex. Okay, when all the ligands are removed along with their shared electron pairs. So when the electrons, now you know, so metal is there and it is linked to what? It is linked to the ligands. So when the ligands are removed, so what is the overall charge on this particular metal? So that we are going to find out. So the oxidation number, we are going to find out the central metal atom. So how it is, suppose, okay, please note it down, very important. So I'm giving you examples, and this is a tetracarbonyl nickelate. Okay, tetracarbonyl nickelate. 4 carbonyl groups are there, so we write it as tetra. So tetracarbonyl nickelate. Okay, so what we have, which is the central metal atom here, students? Which is the central metal atom? Which is the central metal atom? Nickel, very good. So nickel is a central metal atom. So we'll keep it as X. So let X be the coordination number. Okay. And how many carbonyl? So carbonyl group, the value is 0. Okay, it does not have any charge. Okay, it is a neutral molecule. So plus 4 into 0 is equals to 0. So what is x? X is equals to 0. So there is no charge on the nickel group. Okay, there is no charge on the nickel group. So let us find second one. So second one is copper. Okay, NH3 4 plus 2. Okay. Yes, tell me. Here also amino group, it does not have any charge. Okay, any charge. Find out. So now how you are going to write it? So copper is X plus 4 into amino is also a neutral ligand. So into is equals to there is a overall charge. So you have to write it as plus 2. Yes, find out now. What is the charge? What is the charge of the central metal atom? Yes, that is x is equals to plus 2. Very good. Okay, so the charge on the copper is plus 2. Very good. Okay, next K4 FeCN6. Okay, so Cn has mm, -1 charge. X. Yes, see what is the charge? So I told you, okay, if you don't write K4 here, okay, what you have to do, you have to take the charge as -4. So what I have written, so I'll take the charge that side. Okay, so what it will be x plus 6 minus, so what it will be x minus 6 is equals to -4, x is equals to -6, x is equals to -4 plus 6, x is equals to plus 2. So the charge I'm getting as plus 2. Everybody else understood? So now, K, if it is K4 FeCN6, right? So what I will do, instead of writing K4 here, I can write it as -4. So I'll take like this. So x plus 6. So here, okay. Remember that cyano has -1. Okay, cyano has -1. So this you have to remember. Water has 0. Sorry, yes, water has 0. Amino has 0. Charge is 0. Okay, then your fluorine, bromine, okay, chlorine, it has -1. What it has? -1. Okay, so these things you have to remember, okay, for finding out the charge on the central metal ion. So what we are finding? We are finding the oxidation number. We are finding the oxidation number of what? Central metal ion. Not, okay, we are finding the central metal ion. Yes. Next, PT F6 -1. Yes, find out. Now this you have to find out. I've told you just now. So carbonyl has 0, amino has 0 charge, water has 0 charge, cyano has -1, fluorine, chlorine, bromine. Okay, so this has all -1. So use this and tell me what will be the charge. So your central metal atom is what? Your platinum. So X plus. Yes, what you have got? Okay, very good. Baby has got it as +5. Very good. So this is F is 6 into -1 is equals to -1. X -6 is equals to -1 is equals to -1 plus 6. So it is 5. Very good. Yes. Yes, Shrivaruni has also got it as +5. Now, I hope you have got it. So find how to find the oxidation number of the central atom. Okay, how to find the oxidation number of the central atom. Yes. So let us move for the nomenclature. So let us move for the nomenclature. Next, we are going to discuss what? The nomenclature. Okay. Nomenclature means how to write the coordination compounds. How to write the coordination compounds that we are going to discuss. Okay. We are going to discuss what? How to write the coordination, how to name the coordination compounds. Okay. So let us see the nomenclature of coordination compounds. So according to IUPAC, okay, according to IUPAC, so there are some of the rules, okay, while writing the or while naming the coordination compounds. So what are the rules? So first rule is that order of naming the ion. So how you are going to this what follow the order, how we are going to follow the order. First one is order of naming the ion. So in both positively and negatively charged coordination entities, the cation is named first. Okay. So whenever we are writing order, okay, order of naming and naming the ion. Okay. So if you have both cation and anion entity, what you are going to write? You are going to name the cation entity first. Cation means what? Cation means with the positive charge. Okay. And anion means what? With the negative charge. So whenever you are writing the order, okay, which order you are going to follow, you have to write the cation first. Okay. Positively charged ion should come first, and then you have to write the name of the anion. So first, let us see. I'll take an example, this one. K4 FeCN6. Okay. So K4 FeCN6. K4 FeCN6. Okay. So here, now if we have both. So your positively entity is there. Okay. And then you have this negative entity. Okay. So what first? So this is a positive entity and this is a negative, because if you remove K4, this becomes -4. Right. So how we are going to name first? So both positive and negative entity are there. So first we are going to name the positive cation. Okay, so K plus. So K plus is named first, and then FeCN6 group is named later. Okay, so this you have to, first you have to name this and then you have to name this. Okay, next we'll see one more example. So copper NH3 4, okay, and SO4. Now here, what you're going to name first, which is the positive entity? Please see the charge on sulfate also. What is sulfate? Sulfate charge is -2. So which will come first? Which is the positive entity? Your copper complex. Okay, so this you have to name first. First you have to name this and then you have to name this one. Okay, so your copper NH3 4. So if you do not write this sulfate, so this will be +2, because the charge on the sulfate is -2. Right, the charge on the sulfate is -2. So you have to name this first entity. Got it now? Understood? So whenever any complex is given, so the positive entity is named first, the cation is named first, followed by the anion, followed by the anion. Okay, now this was the first one. Okay, this was the first rule. Second rule, naming of complex ion. Okay, naming of complex ion. First was the order. So when we are deciding the order in between cation and anion, cation should name first, followed by the anion. Now, when you are naming of complex ion, so in naming the complex ions, your ligands, okay, are named first. So ligands are named first. Okay, ligands are named first. Then central metal atom. Then will be your central metal atom, ion. So first will be what? Your ligands. So first will be your ligands. So ligands will be named first and there will be your central metal atom. Okay. the coordination number of the metal ion is also expressed. So whenever they are central metal atom, so just now we saw platinum, Fe6. Okay, platinum, Fe6 minus 1, right? So when you are writing the name, what you are going to write the charge also. So platinate. Okay, so the some of the names are given and you have to write it is 5. Okay, you have to mention it in Roman number 5 like this. So the charge of the this also should be written. Charge also should be written of the central metal ion in Roman numbers. Okay, in Roman it should be written. Okay, just after naming the metal ion. So suppose, so what is the sequence? So what sequence you have to follow? So the sequence is, okay, first name of the ligands. Okay, name of the ligands. And then what? Name of central metal atom, central metal, okay, ion. Okay, then next is oxidation number of metal. Okay, so these are the steps. These are the steps you have to follow. Let me give you example. Now you have to tell me now. So after applying these two rules, you have to tell me how you are going to write this name. Yes. Tell me the name. First will be the name of the ligand. Yes. How many cyano groups are there? How many cyano groups are there? There are 6. 6 means it is hexa. Okay. Hexa, hexacyanido, hexacyanido. Okay, hexacyanido. Then ferret, ferret. Okay, what is the charge? What is the charge of ferret? Ferret. Find out. X plus 6 into minus 1 is equals to minus 3. What is the charge? What is the charge? It is plus 3. So it is 3. Got it? So like this you have to follow. Like this you have to follow. So hexacyanidoferret 3. Hexacyanidoferret 3. So first one, what was the first rule? First rule was order of the naming of the ion. So between the cation and anion, cation should name first and then will be your anion. Okay, so we have seen two types of the complexes. So you might have got the idea. Okay, so which is the cation, which is anion, how to find out. Next is second rule was naming of the complex ion. So first you have to name the ligand, then you have to name the central metal ion, and then you have to give the oxidation number of the metal ion. Okay, oxidation number of the metal ion. So this is the second rule. Fine. Next, now how to name the ligands. Okay, how to name the ligands. So we told. So these were the two main, what you can say, rules. So these are the two main rules. Now we will see how to name the ligands. Okay, first one is, so A, name of ligands. Okay, name of ligands. So order of naming ligands. Order of naming ligands. So how to give the order? Okay. So if you have more than one type of ligands are present in the complex ion, okay, if you have more than one type of ligand, if it is present, then you have to follow alphabetical order. You have to follow what? Alphabetical order. So if you have more than one type of ligand, what you have to do? You have to follow the alphabetical order. Okay, alphabetical order should be used. Okay, suppose this is a complex. So this is a complex. So cobalt, then you have NH3 4, then you have NO2, and you have Cl plus 2. Okay. Now tell me what will come first. Now tell me what will come first. So this
Chlorine.
is named as, what is the name here for your NH3? It is
Ammonia.
amine. Ammonia, no, it is amine. Okay. So this is amine, AMMINE. So it is named as amino. Okay. It is named as amino. Next, next you have nitro group. Next you have chloro. Now you tell me. So between the ligands, okay, between the ligands, which is the alphabetical order will come first? Amino, right? First will come your amine, then will come your chlorido. Okay, so this is the chlorido. So the name given for chlorine is chlorido. Okay, it is chlorido. And then is your nitro. So, and you have to use, so for 4, what you are going to use? So if it is 2, then you are going to use di. If it is 3, tri. If it is 4, tetra. If it is 5, penta. Okay, if it is 6, hexa, hepta, and so on. Like this you are going to use. So how many amino groups are there? How many amino groups are there? 4 amino groups are there. So how we are going to name? We are going to use, okay, we are going to use tetraamine, like that. So this is clear, order is clear. So whenever we are naming the compounds, okay, whenever we are naming the compounds, okay, first we have to name the ligands. And when you are naming the ligands, we are going to use what? When you have more than one type of ligand, we are going to use the alphabetical order. We are going to use the alphabetical order. Okay. So here we are going to use tetra. So tetraamino. Okay, tetraamine, chlorido, nitro, cobalt. Okay, what is the charge on cobalt? What is the charge on cobalt? So, so X plus 4 into 0. Nitro is -1. Okay, nitro is -1. So write it as minus, and this is also -1 is equals to 2. Okay, so X 4 plus 0 is 0. This is -1. This is -1 equals to +2. So X minus 2 equals to +2. So X is equals to 0. So the charge on the cobalt is 0. Okay, the charge on the cobalt is 0. Yes, fine. So this is plus, or it is becoming 4. Let's see what will be the charge. So this is X is equals to -2 equals to +2. So X is equals to +2, and this will become +2 or becomes +4. Charge will be +4, I guess. Okay. So the charge will be +4. Okay, charge will be +4. Fine. For like this, you have to remember the order. So first cation followed by anion. Second is what? You have to name the ligand. So when you are naming the ligand, when you have more than one type of ligand, you have to use the alphabetical order. When you have the number of ligands, okay, depending upon how many ligands, you have to name it as di, tri, tetra, penta, hexa, hepta. Okay, like that. So this is the second point. Next one. Next we will see. Okay. Next we are going to use the names of the anionic ligands. ends with O. So whenever you have anionic ligands, okay, remember that whenever you have anionic ligands, now which are the anionic ligands? Cl, NO, okay, then cyno, then you have fluoro, you have Br. So these are the anionic ligands. So whenever you have anionic ligands, okay, that is negatively charged ligand, okay, so what will have? It ends with 0, O. It ends with O. Okay, remember that. So anionic ligands, whenever you have anionic ligands, okay, that is negatively charged ligands, so they will end with O. Okay, so in general, if the name of the anion ends with, suppose it is chlorine. Okay, if it is chlorine, so your, or if it is chloride, okay, we'll take it as chloride. Suppose if it is chloride, okay, your IDE, okay, your IDE will be replaced by O. So it is what? Chlor, chlor, chloro. Okay, it is chloro. Okay, it is chloro. So IDE will be replaced by O. So in general, if the name of the anion is ends with IDE, okay, ITE, if it is IDE or it is ITE, okay, or if it is ATE, then the E, okay, only E, not IDE completely, okay, only your E is replaced by O. Okay, it is E is replaced by O. So what is the name? It will be chlorido. Okay, it will be chlorido. Remember that. So remember this. So here, whenever any anions are there, okay, then suppose now cyanide. So what will happen? Your E of the cyanide will be replaced by what? Cyanido. Got it? Got it? Okay. So, so whenever this is there, any negative ion is there, and it is ending with IDE, chloride, fluoride, okay, fluoride. Now your E will be of fluoride is replaced by what? Fluorido, like that. So the name will become fluorido. Bromide. Okay, if it is bromide, E will be replaced by what? Bromido, like that. Okay, got it. So like this. So whenever you have IDE, ITE or ATE, your E is replaced by O. Only E, not full. Only O is E is replaced by O. Okay. And so it will give you what? IDO. It will give you ITO or it will give you ATO. So if it is replaced by E is replaced by O, it will give you IDO, ITO or ATO. Okay. And if you are naming your neutral, so this is about anion ligands. If you have neutral or cationic ligands, if you have neutral or if you have positively charged ligands, okay, they are kept as normal molecules. Okay, they are kept as normal molecules. They are kept as normal molecules. Okay. However, some exceptionals are there. Okay. So H2O is named as aqua. Remember that? H2O, water is named as aqua. Then your NH3 is named as amine. Okay, it is named as what? Amine. Please note it down. Please note it down. Very important. Okay, very important. So this you have to know while you are naming the compounds. Okay, so this also please write it down. Okay, so this you write it down. Now, then, so these are the exceptional case. So whenever you have neutral or the cationic ligands, okay, then they are named as normal. So few exceptions are there. Okay, where water is named as aqua, NH3 is named as amine, then CO, okay, carbonyl. So this here, now here, okay, nickel CO4. So this is your what? This is your carbonyl group. Okay, this is your carbonyl. And here NH36, this is what? This is your cobalt. Okay, so don't get confused. So don't get confused. So between the nickel, this and this, so this is CO, this here it is carbonyl group. This is a ligand. Okay, and here it is a central metal ion. Okay, this is a central metal ion. Okay, so CO is represented as so CO. Okay, carbonyl. Then NO. If it is NO, then it is nitrosyl. Okay, it is nitrosyl. So these are the names which are given. Okay, these are the names which are given. Did you note it down? Yes, did you note it down? So I'll
Yes,
give you
ma'am.
some more. Yes. So let me give you some more. So whenever anionic ligands are there, so your IDE, ITE, ATE, if it is ending with this, so your E will be replaced by O. Okay. And whenever you have neutral or cationic ligands, then they are given the common names, that is the normal names. But there are few exceptionals where exceptionals, okay, water is named as aqua, NH3 is named as amine, CO, that is carbonyl, and C. Cobalt is represented this way, and carbonyl is represented by like this. Okay, don't get confused. So this is your ligand, and this is your central metal atom. Okay. So CO is carbonyl and NO is nitrosyl. Okay. Few more names. So negative anionic ligand Cl minus what it is? It is then chlorido. Okay, please note it down. Br minus is bromido. Bromido. Okay, so these are the names which you have to know. NO minus is nitrido. Nitrido. Okay. NO2 minus nitrido. Then OH minus is hydroxido. Okay, then Cn minus is what? Cyanido. Then O2 2 minus is peroxido. Peroxido. PERO. PEROXIDO. Okay. Next is O2 minus. It is oxido. Then CH3 COO minus is acetato. Okay. Then SCN minus is thiocyanato. Thiocyanato. Okay, thiocyanato. Then NCS. It is isothiocyanato. Okay. Then H minus is hydrido. Hydrido. Okay. Next, ClO3 minus is chlorato. Just a second. Okay. So ClO2 minus is what? Chlorato. Okay. Next is NH2. NH2 minus is what? Imido. Imido. Then CO3 minus 2 is your carbonato. Carbonato. Then SO4 minus 2 is sulfato. Okay, it is sulfato. Is it clear? So these are the negative names. Okay, how you have to name the negative ligand. So these are named the negative ligands. Negative anionic ligands. Okay, negative or anionic ligands. Is it clear?
Yes, ma'am.
Yes, okay. So next are few names of neutral ligands. Okay, so these are some of the, please note it down. Okay, very important. So when we are going to, so nomenclature is asked. Okay, important question asked only for your CET point of view. Also, it is important for all your competitive exams. Okay, coordination compounds. So by knowing this base, that is how to name the compounds, then only you can name the compound. So for board as well as for your competitive exam, so this is a very helpful thing. Okay, so for neutral compounds, so if you have NH2, CH2, CH2, NH2, okay, this is what is the name? It is ethylene diamine. What is the name? Ethylene diamine. I'll write the name here, okay? Ethylene diamine. Ethylene diamine. Okay, ethylene diamine. Okay. Next is C6H5N. What is the name? It is pyridine. It is pyridine. Pyridine. Just a second. It is pyridine or pyridyl, or it is pyridyl. Okay. Then one more CH3. I'll write it down. See, this is a neutral. Examples of neutral. CH3PH2. It is methyl phosphane. Methyl phosphane. So these are some of the neutral ligands. Okay, these are the neutral ligands. So please study. So today we have seen two main rules, that is order of naming the ion and then naming the complex ion. So in naming the complex ion, we have seen order of naming the ligands and then naming of anionic ligands, okay, and naming of neutral ligands. Okay, so so few more rules are there, and then we will give some of the examples. Okay, some of the names. This will solve some of the examples on that particular compounds. Okay, how to name the compound. Is it clear up to here?
Ma'am. Yes,
Yes.
ma'am.
Okay, fine. Okay, so practice these things. Okay, whatever I have told. So please remember all this. Note it. Okay, so because tomorrow, after giving the other rules, then we are going to name the compounds. So that time by using this all rules, okay, by using this all names, you have to, okay, if I give you the compound, you have to apply this all and you have to start giving the names of the compounds. Okay, fine. So any doubts up to here?
No, ma'am.
Okay, fine. So I'll end the session here. Okay. So the remaining things we shall be discussing in the next class, tomorrow's class. Fine. So thank you. Have a good